Part 2 of 1.4 radicals. Between last class and today, one thing I want to let you know is that I rewrote this little guy right here, this paragraph. Your paragraph was really big that you took notes on, and as I was reading them, I thought to myself, man, I really want to try to see if I can make this make more sense. So here's what I did between last class and today. I rewrote this to factor coefficients inside radicals into smaller parts. I kind of made that a little bit smaller. Circle any pairs. Write one factor outside of the radical per pair. I simplified it to that. And then anything in front multiplies factors that break out, including negative and plus or minus signs. And always simplify by multiplying. I keep writing that inside with inside. So I try to make this a little bit smaller for you guys, or maybe even for next year's classes. And so I want to review with you what we're doing so that you can see. Step 1, break it apart. 2 times 12. And it doesn't matter what you break it apart. 4 times 6 would work. 8 times 3 would work. If you break apart those pieces, 12 can break down to 2 times 6. 6 can break down to 2 times 3. If you look at what 24 is made up of, it is 2 times 2 times 2 times 3. If you have a pair, you circle any pairs. There's a pair of 2s. When you circle the pair of 2s, what can break out is one of the 2s per pair. So if I circle it and I go like this and I cross off 2 of them, one of the 2 can break out. It's the way I explained it in my 4th period class was, think of this like jail. And when you're in jail, you can't get out of jail unless you have a partner that you can somehow make a plan to break out. Usually what happens when somebody tries to get out of jail, one of them gets shot on the way out. So think of it like that. And one gets away, the other one gets hurt. I don't know. Doesn't make it out. There you go. But actually, it's just really because 2 times 2 is 4, and the square root of 4 is 2. That's the real reason why only one of these things breaks out, is because for every pair, that represents one of those perfect things down that yellow diagonal that we talked about with our times tables. Okay? So when I do the problem like number 2, the correct answer should have been 2 root 6. And you are expected to be able to do this without a calculator. And so if you do not know how to do this without a calculator, you're going to get a lot of practice today, because I think there's 24 of these on this worksheet. Number 6, just to review, if there's a plus or minus sign in front, leave it there. We're going to multiply anything that breaks out by that plus or minus sign. So for number 6, the first thing I didn't know what multiplies to be 216, so I just divided it by 2, which was 108. Then I took the 108, cut it in half, 2 times 54. Then I took the 54, cut it in half, 2 times 27. Then I took the 27 and divided by 3 and I got a 9. I took the 9, divided it by 3 and got 3 and a 3. And so what I had was a 2, a 2, a 2, a 3, a 3, and a 3. 2, a 2, a 2, a 3, a 3, a 3. And I looked for pairs. I had a pair of 2s, pops out. Had a pair of 3s, one of them pops out. The 2 and the 3 multiply each other. This 2 and this 3 do not have a partner. They do not have a pair, so you put them back together. What do I do with that plus or minus sign? It stays there. That multiplies this 2 times 3, which is a plus or minus 6 root 6. So I'm hoping that makes sense to you for number 6. I have 3 more examples of how it gets a little bit harder. If you would like to do these 3 more examples on your worksheet, you are welcome to do so. So for number 10, I have negative 6 root 54. The first thing I would probably do is I'd break down this 54. If you know 2 numbers that multiply to be 54, say the 2 numbers that multiply.
6 and 9.
I heard most people say 6 and 9. 6 times 9 is 54, I agree. Now the 6 breaks apart. What numbers multiply to be 6?
3 and 2.
3 and 2 or 2 and 3, doesn't matter the order. Once you break it apart, you're not using it anymore. Once we break it apart, we're not using it anymore. Bless you. Does the 9 break apart? So what I want you to think of is that everything that's a part of the factor tree is underneath that radical symbol. So what that means is that this -6 that's out in front, that's outside. And what's inside this radical, what's inside this jail, are these numbers, the 2, the 3, the 3, and the 3. And this problem's pretty simple after that. Our directions that we wrote down in our notes say that we need to circle any pairs, and one factor can break out per pair. Do I see a pair of 2s? Nope. Do I see a pair of 3s? Yes. Doesn't matter which ones you circle. A 3, one of these 3s can break out. If the other 2 and the 3 don't have any pairs, you put them back together by multiplying insides. Multiply insides, 2 times 3. Now this 3 that broke out, what does it do with this -6? It always multiplies. Outsides multiply outsides. So in front, I have -18, because 3 times -6 is -18. And there's nothing else you can do with this particular problem. Your final answer for number 10 is -18 root 6. So far, does it seem that it's pretty simple? Good. I hope you're on the same page as me with that. How does it get harder, Mr. Promo? Sometimes they're going to have something that's already simplified multiplied by something else that is not simplified. So this is where, in that paragraph, insides multiply with insides and outsides multiply with outsides. I'm reminding you that because the 4 is on the outside. It's going to multiply anything on the outside, and right now there's only this other invisible 1 that's right there. That's on the outside. And then we have this inside multiplied by this inside. They're both inside that radical. I do not recommend multiplying 6 times 27. That would be a waste of your time because you would be making it bigger. With radicals, we want to try to see if it simplifies. To simplify it, we're going to need to make it smaller. So what I would recommend that you do, since you're doing 6 times 27, is I would break apart that 6 into 2 times 3. Make it smaller. I would break apart the 27 to 3 times 9 and 3 times 3. That way, you now know what's on the inside. You have a 2, a 3, 3, a 3, and a 3. Some of you are going to want to rewrite it like I am doing right there. Others of you will be able to see from the factor tree what your pairs are. You look for pairs, you circle a pair. When you circle the pair and you go like this, that's how they can break out of that jail. Cross them off. Do you have any other pairs? Oh, I see another pair of 3s. Breaks out, cross them off. How many break out? Only 1 per pair. And I had 2 pairs, so 2 of the 3s break out. Now, what do I do with the numbers? Anything left inside the radical stays inside the radical. If you have numbers that break on the outside, we multiply 3 times 3 times 4. 3 times 3 is 9. Times 4 is 36 root, or you could say radical 2. 36 radical 2, 36 root 2 is our final answer for number 14. The two key things, insides multiply insides, but break it down, make it smaller. It's going to make it easier on you. And outsides will multiply outsides. Last example, number 23. I have 3 root 7 squared. What I want you to remember is when you see this squared, it means the same thing as 3 root 7 times another 3 root 7. 3 root 7 times 3 root 7. Insides multiply insides, outsides multiply outsides. The 3 and the 3 are outside. I would multiply those two outsides first. 3 times 3. Good. Insides multiply insides. I have 7 times 7. And some of you are going to say, oh, that's 49. But remember what I said. Why multiply those two things when you could just write them next to each other with a dot? 7 times 7, right? Don't make it 49 because you're going to have to break that 49 down anyways. Save yourself a step by just writing 7 times 7. Is there a pair? And now we can follow our rules. If they have a pair, can they break out of jail? Yes, we can. 7 pops out. Then the pair I get to cross off. Is there anything left inside that jail? If there's nothing inside the jail, we don't need any jails. They go away. 7 times 9, outside times outside, is 63. That's our final answer. I'm going to stop your notes right there.